Okay, we are live. Oops. Here. And then do not disturb. Cool. Okay, guys. Sorry about the delay. There was some issues with Windows updates giving me problems, so everything should be all resolved now. Wanted to go ahead and do a few quick little updates on what's going on with everything. First of all, the previous video I did had the audio from some of the music I was playing, and Twitch muted half my video. So as of right now, it is on YouTube but hidden away because I want to make sure people can actually hear what I'm saying and such. Thus, if they go through and do that, I will add it up. If people really want it up there, even with no volume, I can put it up. Split up into two parts. The first 2-hour portion has no audio on YouTube at all. They muted the entire thing, even though there's only 30 minutes of music or something. And then the second video is completely filled with audio. Everything's back to normal. So I can add up that half if people are interested. And I'll make these announcements again at the end for those who come in late, I guess. So let's go ahead and get started. Bring over Visual Studio. Slowly but surely. There we go. This is set up to be my main monitor, right? Yes, okay. Let me just double check how everything sounds. So, and let me know if there's any issues with the audio video. I'm keeping an eye on things, and so far it looks pretty good. But I just want to make sure it stays that way. So, let's go ahead and get the GitHub up running. And to those interested, there are, all of the repos are online. I'm slowly going through and updating them. You can find them down below in the descriptions area. It should be right underneath, oh, where is it? Previous streams. There's 2 GitHub repos, one for the last project, Santa Sleigh Ride, and then one for Breakout Clone Now as well. So you can go through and you can see all of that. New one. Let's name this. Okay, so today's game is going to be a top-down shooter type, or a top-down puzzle game, kind of like those old style games where you had like a simple little maze you had to go through. So what we're going to title this is, I'm just going to call it Maze Game. And initialize with README. Again, license will be MIT so others can do it. Maze Game. Do that. There's that. Close this in the desktop. There. So there's all of that. Just copy that from over here. There's that. So, just going through now and adding in all the include file directories and the third-party libs we're going to need. In this case, we're just going to use SFML again, just because I have a big preference for it, as you probably have noticed by now. Just very easy to get going with everything. So, Alright, now we can get on to the fun parts. There's that. yikes. Oops. Whoops. Oh, that's not the right one. What is going on with my monitors? There we go. Just realized you guys couldn't see what I was coding. That should help a little bit better. Okay. So, just to go through and show real quick all I did. Went through, created our GitHub repo. I will be posting that in the description in just a moment. But our GitHub repo basically just contains all the files for everything. And as of right now, it is containing, the big thing it has is, where is it? It has all of our SFML DLLs in there. It has a game state and third-party libs, and then I went through and I configured it. To configure this, you just go to Properties, and you make sure that you set up your directories. I didn't hard-code the path, I just did relative to where it is. So go out one folder, go into third-party libs, and then put it in the include folder for includes, and then for library, it's just libs. And you go down here to input, you go to edit, you add in these 4 main libraries. That way we can have all of our stuff compatible, or all of the stuff that we need linked in, and then that should be it. And then I went ahead and just did a basic main file with a window. If we run this right now, it'll come up and you will see it'll come up with a nice little window. And it just clears it to black from there and displays any graphics that are drawn to it. And it's got a new title that is Maze Game. So now what I am doing is I am going through and working on the state management side of things. So now that that is slowly getting on its way, go ahead and open up this. So yeah, now we're working on game state. We have tiny state, which we initialize, update, render, destroy within all of that. Then we come down here and we have our actual game state. Go ahead and make us a render window reference pointer. This window is equal to window. Here. Alright, so there's that. Okay, so we have all of that there. Let's go ahead and make our singleton reference. There's that. And then core state set window. And of course, we don't have to use pointers for that. Well, it's easier to use pointers with that. There's other ways that you can reference the object, but it's just a lot easier for us to go through and do it that way. Make sure everything is pretty straightforward with this. Next, we need our update methods here. Void set state, and we have tiny state reference. State. If this state equals none, state finally, what we want to do is here, delete state. Make sure that that's deleted properly. Tiled map editor. Is that, are you talking? Are you talking about this, worst offer? Not sure how to pronounce that. Tiled map editor. I have used it a little bit. I actually haven't used it with SFML particularly, but maybe we can try and incorporate that in to this, because the game that I'm going to be working on today is going to be really based on the entity editor. Is this, I can't remember if this just does tiles though, or if it does everything for a game. I think it's just tiles though. But what I plan to do is to go through and make a top-down game where you have different mazes you have to get through, keys to find, enemies to avoid. Very basic, but a little bit more in-depth than previous the games we've done. The big focus for this will be to show how you can do different entities and stuff using inheritance with different classes. So that's going to be the big focus, so maybe I can integrate that with this a little bit. Not sure how much I will get to, but we can try. Oh, oops. So that's all good. And from here. So yeah, you're getting a lower frame rate because if you, the bigger your map, the more it has to draw and render. Even if it's not being shown, depending on what tools you're using, they'll sometimes still draw it, they'll just not draw it in the view. And so, you know, the more you're drawing, the longer, the slower your game will get and stuff like that. So that's probably why the bigger your map is, the lower the frames per second become. My recommendation for that, and maybe we can show that a little bit, I don't know if we'll have a lot of time to go over things like scrolling in this, but what you can do is you can say, okay, only draw what's needed. If something's off screen, you don't need to draw it. I mean, you can still do the game logic with it. For example, that's why a lot of this stuff I split up into update and render methods, because a lot of the time there's going to be instances where we maybe still want to do the logic for something. You know, if two enemies collide, they shouldn't walk through each other if they're off screen, and if they're on screen, you know, hit each other, they should always hit each other and do something. So we can always do that with our update, but then our rendering, we can say, don't worry about rendering it, it's off screen, we don't need to see that. So that's a really good way to be able to get around issues like that. Okay, so there's that. Go ahead and make our entities. So this is going to be a big focus for this game particularly is the entity class. So I'm going to be going through and doing a bit of copying from over here. If you go to my GitHub page, or if you go to the bottom of the Twitch stream, you'll be able to find Santa's Sleigh Ride from on Christmas Day. In here, go to Santa's Sleigh Ride. There's two big files you'll want. The first one is going to be entity.h, and the second one is going to be entity manager. And we're going to go through these. I'm going to just retype them up so that everyone can kind of see what they are exactly. And then from there we will go through and we will go to entity manager, and we will sort of copy this. We're going to do some other stuff though to make it a bit better. But most of this code is going to be very similar. We're still going to be using ordered maps and stuff, so we get the nice ability to hash things. And then the entities are going to be pretty much the same, if I'm not mistaken. SFML, TMXL loader, TMX loader, TX loader. Let's see what this is. Yep. Ah, cool. So we can load in those tiled map loaders. That might be kind of fun to look into. I'd like to prevent a little bit of this mainly because I really want to focus on how to do a lot of this from scratch. In the future, I'll kind of go through and use more libraries like this, so I'll definitely go ahead and add this to my favorites. Bookmarks. Bookmark this page. Can I not create a new folder here? New folder, there we go. And that's not where I wanted it. There we go. So we'll probably go over that at another point. But today I'm going to focus a lot on, again, going over how you can do some cool stuff with entities and all that. So let's go ahead and get this all started. So again, we need our entity empty loader. Set an active variable later to true here, and we will also set the texture equal to SF texture. Go ahead and add those right here. Active and SF texture. Here, and then code string.h entity string texture. Then we're going to need a load function. String, file name, and set interact texture. Load for file, and then we have file name and rect. There's that. There's that, and we want our active void active int active. Turn this active and int group. Turn this group ID. Load it. Is it from there? Those two, however, should be protected. Separated. And get rid of that. And finally, entity. And in this case, we want to delete texture. And anything else we need to delete? Nope. So there's that. So we have our entity that we can actually render directly with SFML. So if we come into here and we make a simple entity, just render this one. Entity, set upload, make it test.png and sf. Actually, what we can do is we can go ahead and have another load function. This will do that. Use the lag script's awesome little Santa. There's our test image. Reset that. So we're not getting there. Oops. Let's set the state. We have to update it. Core state update. There's that. Is his graphics getting deleted again? Shouldn't be. What's his texture? Yeah, his texture is null. Did I forget to set his texture? I did. Ugh. Not my day. There we go. There we go. Good old Santa up there. Okay. So we got our entities. We have. Now we need to add our entity manager. So. Entity manager. Once again, include what's that? Game state can be closed. Our main. Okay. So, entity manager from last time. Let's go through and see what we did and then go back. JetBrains, C++ IDE, I have not. I think I looked into it though. At one point. Yeah, I've looked at it a little bit. I haven't given it a try though. What is it? It's their not Java 1. Oh, what was it? Here it is. Sea Lion. Yeah, I've looked into this a little bit. I haven't gotten around to using it, but That's more because of the fact. It's more because of the fact that I'm just really used to Visual Studio. I'll probably get to it at some point, hopefully in the near future. But I just like C++ at the moment. Yeah, I really like it for C#. I tried using Mono at one point. It just doesn't compare for C#. C++, I've just kind of gotten into this thing where I either just go straight to a compiler or I use Visual Studio. I feel like if I'm gonna not use Visual Studio right now, I generally just go straight to a compiler. I'm meaning to look though into this. Emacs is something I need to learn more about as well. And I've wanted to mess around with Sublime a little bit more as well, see if there's what exactly I can do with that. I'm still learning it. Right now it's just kind of my special text editor, if anything. So let's go through and do this. Okay, so big things we had were we had an add entity, we had our updates, and we had our reset, and we had render. Okay, so let's go through and add most of that again. Let's see, class entity manager, public, private. We want again our unordered. We're going to want again unordered and vectors objects available. So yeah, no, I agree. Sublime is a fantastic text editor. It is by far the best thing I've ever found. Mainly because I can do all of my web development stuff in it and not have to worry about things not being recognized or Visual Studio taking forever or whatever IDE taking forever at this point. It's just really nice and fast. And I might do a future video of this in Sublime. I might specifically try and do it with nothing but, you know, compiler type thing, going from a really ground up scenario. That would probably be in a future video further in, after I've had a few more to get used to the structure of how I want to do these. But if that's something that's interesting, I think it'd be kind of cool. So, okay, so we have that. Let's get our std unordered map, and we're going to want it to be a string and an entity reference. And entities. And then we want our vector of entities to remove. String to remove. And you know what? We'll just go ahead and we'll put that with our method. It should be fine to do that and should automatically still go through and delete itself. So now we need our entity manager default constructor. And all that's going to do is absolutely nothing. And then we're going to have our void add entity. That'll take in a name and an entity reference. And we're going to have our unordered map, which is of type std string and entity reference, which is found, which is basically going to go through and just search whether our list of entities already has one by that name. And if it does, then while we find these, while we haven't reached the end, we want to basically go through and like adjust the name. So name, we're just going to add on. I was just adding on zeros. It's just a little bit easier that way. And found is equal to this. Entities find name. And that'll let us go through and just kind of search it real easily and not have to worry too much about whether or not we type in something with the same name, or if we want to make a lot of something with the same names, we don't have to worry about conflicting names. To T, and there's that. That'll let us go through and do all of that stuff. And let's go to our update method. And our update method is going to use, again, the auto iterator, which is kind of nice. So for auto and iterator in this entities, if iterator at second active, then what we're going to do is we are going to iterator second update. Do we not have an update method? I do not. That's right, we needed our update methods and entity. So, and finally, with the things I forgot to add are virtual void update, which is just going to update every entity, and virtual void render, which is just going to render them as well. And really, we don't need that though. I'll show you why in just a second. For now, let's go back to here, update. That'll go through and update them all, and then we want to have our render version. Render, we give it the render window reference, and we just come here and we do window draw iterator second. Make sure we do reference that to get its actual value. And there's all of that. And is there anything else that we had down here? Let's go ahead and add in our, that should actually be fine. It should already go through and do that. So yeah, there's all of that. Nothing else specific there. Okay, compile that. Let's go over here to test state, and we'll add in our entity manager. Manager, and come over to our test state. And what we'll do is we'll have, well, we don't really need to do that. Manager dot add entity. We'll name it tester, new entity, and the file name is going to be test.png. And finally, we have manager.update and manager.render, which takes in the window. We have one error. What's that? Entity. Why are you complaining now? Entity times entity. Oh. Const iterator. There we go. So now we have that rendering through the entity manager instead. That'll make everything a little bit easier to manage throughout. So, next up, we are going to do something else. So, we're going to use a type define. We're going to have this be, how do those work again? Void times update, collision update event, and that'll take in nothing. I think that was it, wasn't it? Or was it Deletion, update event, collisions. Okay, cool. So now we will do, we're going to add down here, update collision updates. And that'll be a reference. And here, we will do, how do I structure this? We'll set collision method. Here's that, and then collision event. Here, add that. There's that. And rather than that, it's going to take an entity A, entity. So, there's that. And we will come here and we will add in a private method called void update collisions. That will take in entity A, entity B. Okay. So notice no text drawn out. But what we can do is we can go through and add in a second entity, the exact same position. Let's see here. Should we know? Oh, I forgot. Let's do this first. Let's demonstrate this part. The manager. Set collision method this, update collisions. Just make that finally that needs to be void times void times. That should have worked. Oh, sorry. I guess we're going to cast it. That should have worked. The specific library that I'm using in this case is SFML for graphics. There's our collisions, and we can of course check for specific IDs of each of those, which is nice as well. So, let me see now if I can go through and add that back in. That's going to work. collisions, update collisions. Oh. Wait. Okay, I guess I have to do it this way. It kind of stinks. Oh well. Okay, so there's that. Let's go ahead and add in some test entities. Just name this guy tester again. This will take in tester. What was it to call? Ooh, I need to go through and update the stream name, don't I? Let's change this. This maze game. Man, it logged me in. Logged me out of Twitch. There we go. Hopefully that'll be a little bit better. Update the name now. Okay. Call default, call super constructor C++. I don't remember how to do that. There it is. So in this case, it'll be entity. So there's that, and that'll go through and automatically load that all up for us. And in here we'll set group ID equal to 1. So we have our first little entity guy here. Pretty simple. Technically we probably won't even need the CPP file for him. So I'm actually just going to remove that for now. So he's going to be a pretty easy guy. And then void update, because we need to update him, and keyboard is key pressed. We'll do SF keyboard key up. This move SF vector 2F 0 -1 up down. Left. Right. So that'll be able to move him, and then finally, did we have render method? That's right, we didn't. We only had that. So there's our test sprite. And we can come into here and add new tester. Shouldn't be taking anything in. Ah, that is right. We did leave that there. So we'll just go ahead and get rid of that. G. So there's all him moving around. And finally, we'll go ahead and we'll add in a second entity. We'll call him tester2. He's just going to be a clone of this guy. 2, 2. SFML, SFML, simple, fast media, right? Yep, simple and fast multimedia library. Simple and fast multimedia library. It's basically a image loader, graphics manager, sprite manager, a few other things all in one. Nice and cross-platform and everything, so it's pretty straightforward to use. I like it because of how simple it is to set up and stuff, especially. So here's this guy. Big thing we'll want to do as well, I just realized this, is make tester2 not able to move, keep him in place. We'll go ahead and set his position to set position to and set vector path. Offset him a little bit. So there's that, and we'll go ahead and also color him different just to make sure that we know exactly who he is. So we'll color him set color color blue. So this is tester 1, this is tester 2, and right now they have the same ID, but if we go through, we do this, what we'll be able to do is move him accordingly, and you'll see the text collision appear wherever we're touching him. And that's all thanks to that nifty little collision manager. So the way that this works is in our entity manager. We're creating an event that basically handles all of our collisions, takes an entity A and entity B that are colliding, and we go through and we have in here a collisions event. And what goes on is up here we have this where we set that into this collision event into the other. We can probably get rid of that even. Is that going to yell at us? Nope, that'll work. So, and what that'll do is that will set collisions event equal to that right there. And then if you come down to our collisions, every object we're just going to check for collisions between two objects. And if they collide, we do something based on that. It's not the most efficient way to do so, and the reason for this is that you'll notice we're going through and checking every single object for a collision. And generally in a game there's going to be objects that are never going to collide. You can ignore those in those cases. You really only should be checking certain objects with certain group IDs. So one way we can do that is we can add a list of object IDs that we want to check collisions for. So let's go ahead, and I'm actually not going to do that. This game's going to be hopefully small enough that we can go through and check all of these collisions and there won't be any big slowdowns with it. So it should be okay. The last thing I want to do real quick, and this should hopefully stabilize the stream a little bit better as well now that I'm thinking about it, is we're going to add in a sleep for about 5 milliseconds. That'll hopefully make everything go a little bit smoother in the game. To do that, include Windows, and this should help the stream be a little bit more stable. Our game won't be sucking up as much CPU power then as well. Where did I mess up? Where did I mess up? Entity manager. Where's that going from? Earth. Okay, maybe that's causing issues with that. Huh. Interesting. Okay then. Make sure you include that after or it'll yell at you. So, there's all of that. Again, just to go through and show what we have so far, we have a little character that we can move around, and if we come down here and we collide with this guy who's blue, you'll see that it goes through and says things. So, there's all of that. So, those are some of the big things we've needed. The last big thing that we're going to do is we're going to add a small change over to our objects. What we are going to do is we are going to update this so that it will move based on velocities rather than based on just raw values we get. And the reason I'm going to go through and do this is because it'll just make our lives a little bit easier when it comes to movement and stuff. It's really hard to explain, but trust me, it will. And we're just going to use the SF vector 2f variable velocity. And every frame when we update this move velocity, make sure you know it's coming from in there. And what we can now do is we can come here and we want to call our update what do we call it? Super methods. Void foo. There we go. Entity update. We're going to do that at the very end here. And this velocity x is equal to, this is going to be SF right minus SF left. So that way, if we're not pushing right, but we are pushing left, right will now be 0, but left will be 1, so velocity will be -1. And if we're pushing right, we're not pushing left, velocity for this will be 1, this will be 0, so it'll go to +1, which will move it to the right. You can do the same thing for up and down. Here. And again, same thing, but a little bit cleaner code, and we're using velocities now, so that makes our lives a little easier. And what we can also do is if we come over to entity and we make our velocity vector public, what we can do is some cool little tricks, wherein instead we can move it in the opposite direction. So let's come here, and what we'll do is we'll move entity A if there is a collision between that and something else. So what we'll want to do is we'll do SF vector 2F, and this will be entity A velocity x, and that'll be negative, and the same thing but for the y. And what that'll do is that'll make sure that we're not colliding with it. And you'll see now that we can't touch it. Anytime we do, we just kind of bounce off of it, which is kind of nice. And of course, this isn't a foolproof way. There's lots of ways that you can break this, but it's a good way for simple, basic collisions to start with. And it'll help us to be able to make sure that our character isn't going to collide. There's a few checks we could add in for this, but honestly, I'm just going to keep it like this. So now we have the ability to create effectively walls, and this allows us to do some pretty cool stuff with it. We can of course now do a platformer or something like that with this. That's not going to be really what I want to do though. In this case, we're actually going to go through and make a slightly different type of game with it. So here's kind of our test state. We're going to go through now and we're going to make our main menu again, make it all nice and pretty, and let's go ahead and get started with that. So again, the way that this works is we have a collision event. This is an easy way to go through and create events in C++. You give it the output type. So in this case, set collision method is void. It takes in this parameter. In this case, collision update event is returns nothing, and it's the entity type is going to be, the inputs are going to be entities, so that we can go through and do specific things with those entities, such as bouncing them off of each other. The other thing that we could go through and do as well is we can go through and do things like return which the value, like how many collisions there are in this case. So if they're, or how many objects should be deleted. So if we want to delete objects in an event, we can do that. I'm not going to do that because I'm actually going to have our active variable handle that again. So if we come down here, we check if it's active, say else, iterator. We're going to go through, and at the beginning of this, we're going to create a list of objects to remove. So std vector, and this will just take in string. And again, what it's going to do is it's going to just be called toRemove. And if the object is not active, we're going to add it to the toRemove list. Push back iterator first. And finally, like we did right here, we're going to go through and just remove them until we're done. So we'll just add that on right here at the bottom. And as long as the size of toRemove is greater than 0, we're going to go through and remove each object, pop it off the stack, and then at the very end we'll double check again that toRemove is empty by clearing it. In this case though, because it's not a global it's not declared in the class, we don't need that actually. We just put that there. And so that is all of our stuff completed. So now we can go through and also remove entities as well. And what I'm going to do is I'm going to come here. So when we delete objects, we can return how many are deleted. And what we'll do in this case is we will show how we can do a score system. And this is going to be pretty simple. We just return that we want to delete entity 2. So what it'll be is, and actually, we'll go through here and we'll do a type define enum, and we're going to say entity A is equal to 0, entity B is equal to 2, 1, actually both is equal to 3, and none is equal to 0. And this is going to be called entities and collision return. Call it collision return. And it's basically just going to expect us to give it how many entities were collided. And so in this case, we'll go ahead and we'll say how many entities to delete. So we're going to do collision return, and in this case we will return entity B to delete. And what is yelling at us now? Equal to 0. And otherwise we'll return collision return none. And if we get that, then we're going to want to go through and set that to not be active. In this case, what we'll go through and do is we will add and realistically, actually, we don't even need that. What we can do is something better, I just realized. Go through there. Go through here. Make this even better. Apologies for that. Void set active is equal to active. Entity B set active to 0. So let me update the stream name in just a sec. Go through /SFML maze game. So now we can go through and we can destroy those guys as well. And of course we could make it so that there's different types of enemies that we can destroy. So let's go through now and so now that we've got that, let's go through and actually make the game. Add new. this main menu. Again, call this menu. Once. And we're just going to come over here and copy from the test state and overwrite some stuff. So, in this case, it'll be main menu. And in this case, we won't need that, but we will want to go through and, find a font. But before we do all that, let's go through and actually update this on GitHub so everyone else can download it, follow along. Project, loaded project, baseline with entity manager, game state manager, and test demo, collision management, and test demo. So that'll all be on the GitHub repo, and I'm going to go ahead and post that below in just a second. What on earth? Add all of those then. Permission denied. Interesting. Well, that's a new one. Okay then. Huh. Guess Visual Studio changed the permissions on me. Interesting. Well, now you know what might cause errors. Go ahead and wait for that to upload, and then we'll open the project back up. Oof. It's so slow today. There it goes. Okay. So that's all available on here. Let's go down here and update this. If you go down to previous streams, you'll see it there in just a sec. This will be Maze game. GitHub. That should be on there now. Yep. So if you go ahead and open that up, you'll be able to see the repo and download it and play with it as you please. So yeah, there's all of that. Oh, Visual Studio. Okay, so that's going to be a pain because I'm going to have to close it every time, so it's going to be a little bit longer before I update things. Again, if anybody has questions, you're welcome to post them in the chat. I can answer as best as I can with all of them. So, let's go on. There's that. Okay. Main menu. State. That. Font, text, logo. Let's go find font. Free fonts. That looks pretty cool. And so we'll go ahead and we'll take that, put it into here, extract font. I'm going to put this over downloads. Oops. So we can delete that, add that into here. Logo equal to SF text. And we'll set it to 100 for the size. And then window, draw this logo. Whoop, forgot to set that state. So, there's that so far. So let's go through now, and I don't know if this supports the new line character. Well, let's find out. Oh, it does, cool. So now what we can do is we can move this over a little bit. This logo, set origin, and this will be this logo, get global bounds dot width over 2 2f and then this logo set position and cool window, get size, 2. Technically, I keep forgetting this, but I don't need that either. That'll set it up to be right in the center of the screen, but we only want it up at the top. So let's go ahead and set that to 0. And then finally, I'm going to come here and set this still to 0. So we only want the top of it, the left side of it, to be centered. And there's our maze game background. So we have that working. We can scale it up and everything. Not going to look as nice, but it works. And let's go ahead now and add in our play, quit, and again, I want to go through and set that up. Play, play, play. This 64 units. And didn't appear because we didn't render it. And you can see it's a little too high up still. So what we're going to want to do is take that, and then let's go ahead and add on stop play. Times 1.5f, because it's starting from the, long story short, it's not getting the proper height. So there's that. And what we can do is we can go through, and we need to do the same for quit. And plus this play get global bounds dot height. Put it right underneath. And this is going to be quit. We'll go ahead and make it just play and quit to make it look a little bit cleaner. So there's that. And again, we need to make sure we draw it. And what we will do finally is we will go ahead early and add in the select value. And we're going to do this play set color, and it'll be defaulted to SF color light. Switch. Put it to color RG. Is there a set color? There it goes. 255. Set it to 128. 0, 0. Make it a nice dark red. give it that kind of edgy look this time around. Whoops. And in this case, we need to go through again and set this selected to 0. And again, that should be times 1.5f. Give it a little bit of space between them. And now we have our edgy little red selection there. And what we can also do is, if we really wanted to, we can set the text each time to be something slightly like selected type. Play, set string, play, quit. And then what we'll do is quit. And now what that'll do is it'll make it based on which one's selected, have like a little thingy next to it. That looks kind of cool. Let's go ahead one step further though and make it so that they don't move around like that. Although that actually looks kind of cool, I think. And finally, we need to do our keyboard input. We need to make sure we have our keyboard keys, because again, events are nice, but they are a little bit slower, and so this will keep things at a faster pace throughout. So what we'll do is we'll come here. We're just going to go through and copy one of these. To have up equal that for now, and then down, left, right, up, down, left, and right. And then if SF keyboard is key pressed, SF keyboard key up and not up. So if we're pressing up and the previous key wasn't up, then this selected minus equals 1. Do the same thing for down, and this is going to go there. I just realized we don't need up and down, or left and right, we just need up and down. And so there's that. And then we do if selected is less than 0 is equal to 1. And the same thing for if it's greater than 1, then it should go to 0. And now if we go through and we run this, as soon as it comes up, we can go through and select either one. And then what we'll go ahead and do to finish it off is allow for you to actually use them. So let's go through now and do if SF board is key pressed SF turn, then switch this selected case 0. We're going to do for state, set state to new, test state, right, and case 1. We need to add in a variable to quit the game. So first off, let's make sure we include test state here. And that'll allow us to use that. And then quit game is going to be equal to true, and what that's going to be is a variable over in our game state class that basically says whether or not we can quit. So xturn bool exit quit game, over to main, we say if quit game window close. Yeah, the reason that this is used in the code is to make sure that there's no confusion on where variables are coming from. The idea is that if you're referencing a variable in a class, so in this case we're going to be referencing, for example, the selected variable in the class, you know that it's coming from within the class and not somewhere else. It'll help to kind of keep things organized so that you're not getting too confused as to what's going on throughout it. If you're reading the code later on, or somebody's watching a YouTube video of this later as well, there won't be any issues. So in this case, our initialize function ran into some issues. Let's see what's going on here. Unable to read memory. So it went through and had some kind of issue. So let's go through and step through and see what's going on. Oops. Ooh. Now this is why we need that. So you noticed I only put delete state. That was deleting the state from here. What we wanted to delete was this state, the previous state that we were using. So we'll go ahead and do that. And again, it's little things like that that'll be easier to read when I'm not having to go through and do weird things. In this case, we got an access violation. This is null. So where is that coming from? That's somewhere in test state. Update. Active. Where is that? Manager, there it is. And that shouldn't have done that, but it did. This is a good time to point out that you always want to check that these are not null. You know, it's just good coding habits to check that a pointer is not null beforehand. I'm kind of lazy on that. I generally, not gonna lie, I'm pretty bad about that sometimes, but it's still something you definitely want to do. So we'll do the same thing here. And let's go through and try that one more time. Big thing, there's something I was going to change. That's right. I was going to come here and make sure that this was clear as well, what state we were deleting. So let's do that. There's that. So now we have all of that working, and again, we'll come here and come to our test state. And we'll say if keyboard key is key pressed, SF keyboard key escape, then core state set state to new main menu. That'll go through and let us do all of this. Here, get that guy. Ooh, oops. Don't want to do that because that guy's already destroyed. We want to make sure that we do this first. So we only want to set the new state after we're done. Ta-da! So, now that that's done, we have a breakpoint triggered. Again, another little issue running into stuff here. Let's go through and put that there. And that'll make sure that we quit after everything else is cleaned up. Ta-da. Double check some stuff to make sure that we aren't running into issues. The game has triggered a breakpoint. That's a one. Why is that getting into issues? Entities. It's got entities. Got two of them there. And our collision stuff is all set there. Now, why is that having issues? So that shouldn't be. Let's see if we have any issues anymore. This is a quick and easy way to test for things like memory bugs and all of that. As you can see, it's pretty stable. So let's go through now and let's give it a quick pause and see what all is loaded. Good. So we'll go through and normal. Let's check memory usage. Come here and find maze game. So that's our memory usage is 301. Let's double check now what happens when we stop it and start it. Now, this is a really quick and easy way to check something at the beginning. And as you can see, we aren't releasing a resource somewhere. So we need to go through and figure out when. Because as you watch, if I go through and I run it a few times, you'll see the memory jump up to 120 easily. And again, or no, not 120, 70.3, 72.5, which means we aren't releasing our resources somewhere. So let's go through and double check some stuff. And we have all of that there. Let's come up here and make sure, first of all, that we delete our fonts. So, we come up here, we use our font, and then we need to delete font. That'll make sure that that gets released. Let's come up here to entity. So, nothing specific here. We'll go through and just to be on the safe side, we'll do to remove.clear. And then coming further down, we'll go through and when we delete our thingy here, what we'll go through and do is we will have entity manager, and we will go through each object and delete it completely again. Iterator this entities. And we will delete iterator second. and we will do this entities clear. Excuse me. And I'll go through and make sure that we do that. And finally, we'll delete the collision event. And this should hopefully go through and make sure that we have all those same things. In that case, actually, that's not needed because that's a function. We're just going to forget where that is. So that'll go through and do all of that. We'll come up here to test state, make sure we don't have any loose pointers again. Just go through and run it one more time. Oops. And we're already running into an issue here with the logo. This is probably due to the fact that we got rid of the font. So what we'll want to do is we'll want to make this font variable in the class that we can go through and delete later. So let's come here to main menu.h, and we're just going to make an SF font. That way it'll no longer be like that. And .load. Then we got to come here and delete that, and delete that, and then finally we can get rid of that. Yeah, OBS is a little bit of a CPU hog, but I also don't have a graphics card. Graphics card that I ordered is on the way. It'll hopefully be here by next week, which means I'll be able to use it for future videos. So right now we're at about 27.7. We come here, you'll notice that we stay at approximately that. We go up a little bit, nothing huge though. Let's go back and see what goes on. Now, some of these resources might just be C++ not releasing stuff properly. We're going up to 30.5, 32.7. We can go through a few times and run it and see that we are getting massive usages still. Let's go through though and keep doing this because we're growing pretty quick, and it might be just a bug with Visual Studio not releasing resources properly. Let's keep doing this a little bit more. See if it ever jumps back down. If not, we'll just go through and keep searching for where our memory bugs are. You can see we're up to 330.8 and still growing, meaning that our program is not quite right. We still need to go through and figure out more of where these resource issues are. I don't believe that there is a release method in here. And where's our test state? So, test state, we'll go through and just double check here. Nothing specific there. Nothing specific there. Let's go through here. We've got our entity manager deletion. Let's make sure that it's actually getting to that as well. So we'll go into here. Click on that, go back, and you'll notice it's not actually getting into there. It means our entity manager is never actually getting destroyed. So that's going to be a problem. We need to go figure out how to delete those. So let's go ahead and that means our test state is never getting destroyed. So let's come over here and make sure that this is getting called as well. And that is, so now we will go back, and you'll notice again that this is never getting destroyed. So let's make sure that we are doing this correctly. And let's do a quick Google as to why that could be. Because our delete should be called. let's see here. Here's something. So this is